Okay, so this is the last day of new material for Unit 2. We may still have some practice days, but as far as new material goes, this is it. And even then, this shouldn't be new material. I know y'all did a lot of graphing lines in Algebra 1. So this shouldn't be totally new. So yesterday we looked at slope. So just as a reminder, slope, how did we find it? We said slope equals y2 minus y1 divided by x2 minus x1. That's how we found slope. So we're going to use that to help us find the equations of lines, which we can do the equation of a line in several different forms. The one that we're probably most familiar with is slope-intercept form. But then there's also one called point-slope form. However, these will not work for the slope or for a vertical line. Since the slope of the vertical line is undefined, we cannot use these two forms, slope-intercept and point-slope, to write the equation of a vertical line. That's got its own form that we'll see here in a second. So let's look at these different forms. Point-slope form is the one you may not be as familiar with, but we're given a slope and then a point, and with that information, we can write the equation of the line. It's y minus y1 equals the slope, so m times x minus x1. M is the slope, x1, y1 is our point. Notice that we're subtracting here. And they give us this example. They say the slope is 2, the point is 4, 3. So then our equation would be y minus 3 equals 2 times x minus 6. Or minus 4, sorry. I'm looking down at the next one. Y minus 3 equals 2 times x minus 4. Slope-intercept form is the one that you're familiar with, or you're probably more familiar with. That's y equals mx plus b. Of course, m is still our slope. B is the y-intercept. So it's the one that's at 0, b. Wherever we cross the y-axis. So in this example, they tell us the slope is 3, the intercept is 6, so our equation is y equals 3x plus 6. Now, vertical lines. Vertical lines, remember, go up and down. These are the ones that have undefined slope, since they're vertical. Think of it like you're being Spider-Man and you're trying to climb the wall. So wherever we cross the x-axis, our equation would be x equals a, where a is our x-intercept. Because that has to be the x for every point on the line. It's a vertical line. For a horizontal line, those are the ones that go side to side. We want to look for the y-intercept again. So our equation would be y equals b, the y-intercept. Because no matter where we're at on that line, we'll always have the same y value. X will change, but y will not. Okay, so let's look at some examples. They ask us to write the equation of each line in the given form. So A asks us to write the equation of a line with a slope of 3. Let's go ahead and make note of that. Slope of 3 means that m equals 3. And a point, it's got to go through to 1. Our line needs to be in point slope form. Well, which one is point slope form? If I look at my table up here, it's our first one. So let's go in and write it down so we know what to fill in. We have y minus y1 equals m times x minus x1. Well, we know our m is 3. Our point is x1, y1. So now we can just go through and plug in. We have y minus y1 is 1 equals m, which is 3, times x minus x1, which is 2. That's all I wanted. Just plug that in. So we're done. Okay, next one. B asks us to find the line with an x-intercept of 2 and a y-intercept of 3, and it's got to be in point slope form. So in the end, when all the dust settles, we want it in y equals mx plus b form. But let's see what they give us. They just give us the intercepts. Well, what's one way I can write the x-intercept of 2? We could write that as a point of 2, 0. The x-intercept would be 2, 0. If the y-intercept is 3, that's our point 0, 3. But then also, what letter stands for y-intercept? We look in our chart, it's B. So this also means that B equals 3. Well, we know our B already. Now we've just got to find M. Good thing we have 2 points, and we spent yesterday looking at slope. We can use that to find we can use the 2 points to find m, our slope. So just as a reminder, we said it earlier, but m equals y2 minus y1 over x2 minus x1. So I'm going to use this top point as x1, y1, and this bottom point as x2, y2. So y2 is 3 minus y1, 0, over x2. x2 is 0 minus x1, which is 2. 3 minus 0 is 3. 0 minus 2 is negative 2. So that means our slope is negative 3 over 2. I've got my slope, I've got my intercept. Looks like I can make my equation. Y equals negative 3/2 x plus 3. There's my equation. Okay, next one. The line through 0, 4 and negative 1, 2 in slope-intercept form. So what form is that? Y equals mx plus b. Okay, well, this 0, 4, this is my y-intercept. So that means b is equal to 4. Great. Now I got to find m. So label our points, x1, y1, x2, y2. And then use our slope equation. M equals y2 is 2 minus y1, that's 4, over x2, so negative 1, minus x1, that's 0. 2 minus 4, negative 2. Negative 1 minus 0, negative 1. Negative 2 divided by negative 1 gives you positive 2. Well, now I know my slope. I know my y-intercept. So that means my equation I can fill in. Y equals 2x plus 4. There we go. Oof. I just worked example B wrong. Did I put that in the right form on B? No. Mr. Schultz would have gotten the question wrong. Whoopsies. Beep, beep, beep. Put it in reverse. We wanted B in point slope form. That's y minus y1 equals m times x minus x1. We're still going to use the same x1, y1, but putting it in the form they asked, not the form I wanted to put it in. I even highlighted it, and I still got it wrong. We have y minus, what's our y1? It's 0 equals our slope, m, -3/2 times x minus x1 is 2. There's the right answer. It helps when you put things in the format that they ask for it. So don't make the mistake that I made. Make sure you read and write down what it's asking. I would have gotten that question wrong. Okay, on to the back of the notes. So now we're going to work on graphing. Graph each line. Okay, let's see what they give us on this first one. They have it in slope-intercept form. So my m is 3/2. My b is 3. This b, remember, is our y-intercept. So on the y-axis, I'm going to go and I'm going to put a dot at 3. Now remember, the slope being 3/2, that tells me my rise over my run. Rise over run. So from my point, from my intercept, I'm going to go up 3, 1, 2, 3, over 2. I'll always go over to the right till I run out of room. Then I've got to go down 3, left 2. That way I get a good idea of how my graph looks. And then try to draw a straight line. Now this is where you can really laugh at me because I can't draw a straight line even if my life depended on it. Without a ruler, it ain't gonna happen. Oh wait, I have a ruler on here. I'll make it happen. It's got to happen. There we go. I had to make it happen. Okay, there's our line. Okay, now the next one. This one is in point slope form. So our slope here is the -2. But then our point, remember, we have a minus here usually. So we've got to take the opposite point. So y isn't going to be +3. Y is going to be -3. X won't be -1. It'll be +1. Because our formula has a minus in it. So that's the point we want to start at. 1, -3. And then our slope tells us to go down 2 over 1. That's what this slope, when we say slope is -2, think of that as being over 1. So you'll go down 2, right 1 each time. Down 2, right 1. Down 2, right 1. Till I'm out of the room, then I gotta go the other way. Then I'll get my ruler out, since we've already established I couldn't draw a straight line if my life depended on it. Nope, too much. There we go. Close enough. And then the last one, x equals 3. What kind of line do we know of that starts off with x equals? A vertical line. If you didn't know that, look at the front of your notes. So I'm going to go where x is equal to 3, put a dot, but don't just stop there. I see so many people stop there, and that's not right. You still need to put a line through here. Still draw a vertical line. Spider-Man can't crawl up a dot. He can crawl up a vertical wall though. There's our vertical line. Okay, so now let's look at different pairs of lines. Again, we have parallel lines, which we learned yesterday meant they had the same slope. However, they had different y-intercepts. Same slope, different y-intercept. Intersecting lines have totally different slopes. So as soon as you see the slope is different, they intersect. End of story, case closed. Coinciding lines mean they have the same slope and the same y-intercept. Or they're basically the same line. just written a little differently. So let's determine, based on our equations here, if these lines are parallel, intersecting, or coinciding. So if we look at the first one, let's check the slopes. Slope of 2 here and 2 here. So these have the same slope. Now look at your intercepts. 3 and -1. Are those the same? No, they have different intercepts. So what kind of line are these? We've got same slope but different intercepts. Parallel. On to the next one. So this first equation is done for us. We don't have to do anything. The second one, though, requires a little bit of work. We need to get y all alone. So let's subtract 6x from both sides. It's going to give us -2y equals -6x plus 10 divided by -2. We're going to get y equals -6 divided by -2 is 3x. 10 divided by -2 is -5. Now let's look. Okay, what do we notice about slope? Oh, looks like we have the same slope, so I'm going to note that. We've got the same slope. Now let's look at our intercepts. We have the same intercept. So which one has the same everything? Coinciding. Coinciding means they're the same line. As we can see, these are the same line. Once I worked my magic, they came out to be the same. Okay, now for the last one. Looks like on this first equation, we've got to work a little bit of magic. We've got to get y by itself. So subtract 3x. It's going to give us 2y equals -3x plus 7 divided by 2. We're going to have y equals -3/2 x plus 7 over 2. Okay, there's that line. That one's Gucci. Now what about this other line? Got a little bit of magic to work. We've got to divide by 3. We're going to get y equals 4/3 x plus 7/3. Okay, time to look at our slopes. -3/2 and 4/3. Are those the same? No, we have different slopes. Since we have different slopes, what's that mean about them? They're intersecting. Okay, so that's it for the notes. Stay tuned for the guided practice.